Good morning, everyone. Welcome to week 9, where we talk about vectors, in particular applications of vectors. So this is our third week for vector and the last week for vector. So first 6 weeks was linear algebra. Week 7, 8, 9 is vector. Week 10 and 11 will be complex numbers. And week 12 is revision and exam preparation, exam tips, any questions you might have. Okay, we'll begin with acknowledgement of country. We respectfully acknowledge the traditional custodians of the lands on which we work and learn. We pay respect to First Nations people, the elders past, present, and emerging, for they hold the memories, the tradition, the cultures, and hope of Aboriginal and Torres Strait Islands people. Aboriginal and Torres Strait Islands people should be aware that this course may contain images, voices, and names of deceased person. Right, so quick recap of week 8. So week 7 was all about introduction to vectors and a couple of basic stuff. Week 9 was mostly various type of multiplication. So multiplication of two vectors. So we consider dot product, cross product, vector triple product, scalar triple product, summary of multiplications. We had that nice fancy chart. I hope that's helpful. If you haven't seen that, please go back and play it, take a screenshot, take it with you in the exam, because I really spend decent time developing that resource. So it's helpful to everyone who is listening to me or following me. Okay. Then we get started with today's content. So week 9. Okay. Right. An aeroplane is heading to the northeast 45 degree. So sometimes we will be sometimes we'll be given the angles, but if it is a standard angle, we won't be given them. We won't be provided with one. For example, if we are saying that northeast, so north and east, the middle angle, right? So that's 45 angle. Similarly, northwest is also 135, right? So these are kind of standard angle. It should be very clear and familiar with us. So obviously we know that's the north, that's the east, yeah, west and south, anything in between, they are all known. This is 45, this is 135, and we keep going, right? So if they are standard direction, you may not be provided with the angle that is making with the x-axis, okay? Okay, so aeroplane is heading northwest 45 degree with an airspeed of 800 kilometers per hour. A wind of 60 kilometers per hour blows from the southeast. So it's given south, east. So negative 30 direction, right? I think it's southwest. Okay, no, southeast, that's fine. Yeah. Find the ground speed of the aeroplane and the actual direction of flying. Okay. We'll start with the two vectors. Yeah. Okay. Yep. Yep. So we'll start with two vectors. Let's start with, you can pick up any names you like. I prefer something that has a word of that vector. So this is my vector A, and for wind, I will pick up vector W. Okay, so let's start with vector A. AXI, AYJ. That's our vector. Okay, and the another vector, the wind vector, is WXI, WYJ. Right. Now, let's focus on AX first of all. The X component is R cos theta. The length, which is 800, cos theta is cos 45. So from R cos theta, that is 800 cos 45. Cos 45 is 1 on root 2. So that will be 800 on root 2 or 400 root 2. Yeah, I'll write 800 divided by root 2. Similarly, AY is R sine theta. Cosine sine at 45 degrees, they are same. This will be also 800 divided by root 2. Okay, so that's our xn, ax and ay. Now we talk about wx, right? So you can talk in many ways, but since that is negative 30 here, right? Or 30 direction, so negative 30 because it's a south, this is east, so that's this direction, right? You can form an angle and talk about that this is going to be 150 from this one, right? Okay. So we can say WX is, what's the length? 60. So 60 cos 150. Cos 150 is 180 minus 30. You can always use your calculator. I prefer to do it in my brain. That's important. Cos is negative 30 is root 3 over 2. So can I say minus 60 root 3 over 2? And you can simplify that minus 30 root 3. WY will be 60 sine 150. Sine, second quadrant, sine is positive. Sine 150 is 180 minus 30. 60 times half. That's 30. I got both my vector A and W. Okay, we wanted to find the actual speed, the ground speed. So what happens? Like I explained it briefly when we are talking about a vector in week 7, I believe, right? I'll talk about similar situations so we can connect. That's a form, right? Even if I'm pushing that by a bit, it's moving. But let's say there is some another force from the opposite direction. My force is say 5 Newton. There is the other force which is restricting my force by 1 Newton. Then the actual force I'm applying is 4 Newton. Same thing goes, forget about this aeroplane or this thing, bicycle. I'm sure all of us would have driven a bicycle or a bike or even a car, right? If you're going uphill, you need to accelerate or have more pedal, right? If you're going against the wind, so your normal situation, no wind, neutral wind, then your speed could be, let's talk about bicycles. So it could be about 30, 40, depending on how far. The wind. So you are going at the same speed, 30 or 40, wind blowing in the other direction, opposite direction, will slow you down. If the wind speed is 5, your speed was 30, your actual speed is 25. If the wind is pushing you from back or you are going downhill, the gravitational is helping you. If you're going uphill, gravitational force is restricting you. So all that kind of thing. We will add or subtract, this the actual speed. Okay. In this instance, the vector v is the vector addition of both of it, right? The dotted line, as you can see. So let's first of all talk about the velocity vector v, which is the aeroplane actual speed and the wind speed. So this is axi ayj. This is wxi wyj. Ax was 800 divided by root 2 or 400 root 2. Yeah, you cancel 2. Ay was the same, 400 root 2. J wx is minus 30 root 3I. And this is 30. Okay. We collect the I and the j term. So 400 root 2 minus 33 I. 400 root 2 plus 30 j. That's our vector v. You can call it vxi, vyj as well. Next step is we wanted to find the vector. So you can say you already found the vector, which is fine, but this is not that helpful if you look at that way, right? But if you talk in terms of the polar form is, say, for example, if I have to talk about this one, right, then I can say that is 845 degrees. That makes sense. It's nice, it's simple, and you don't have to go too much into detail about its motion is flowing from ij coordinate, because ij coordinate is not always helpful, right? But if you say in the polar form, that's making an angle 45, so keep going, right? It will be anywhere at that point. Okay? So let's go one more step and find the polar form. How do we find the polar form? R and theta. How do you find the R? R is the square root of the x and y component. So if I change my pen color to blue, this is my x, this is my y. Okay. So next step is V is equal to R and theta, where R is equal to square root of those both horrible things. For convenience, I'm writing Vx and Vy. I hope you will understand what I'm writing. Or I can also call it Vx, Vy here. Don't get confused. Yeah. Right, Vx, Vy squared. So that will be, you could have simplified or talked about a decimal in there. I keep it like this. And then you simplify this number, square it, simplify the other number, square it, and take its square root. That's going to be 786 plus 0.608. Now we talk about theta. Theta is tan inverse of y on x or vy over dx in our situation. We got vy, we got vx, right? Tan inverse of that number, whatever that is, dum 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 dum, and that number comes as 9.23. Okay, that number comes as 4923. Finally, for B is equal to R, which is 786.6088, and the theta is 4923. Sometimes radian number is helpful, but when we are given every information in the degree form, it's better you keep it in a degree form, right? So make sure your calculator is providing you in degree form. Sometimes I'm overthinking, so you might be thinking, oh, yeah, but I was looking at this number and thinking forward. So it was going at 45 degrees, remember? And there was some wind in the opposite direction, and we take this 150 degree, right? So what happens? I'm sure everyone's comfortable with 150, otherwise I can explain you again. Change my color and explain it so those who are watching. So what happened? The wind was going 30 direction here, but we need something with the positive x direction, right? So if that one is 30, the other one is 150 because total is 180, right? You could have gone with the other way, but we always prefer the angle with the positive. How much angle does it give between 0 to 180? And that's why we chose the angle as 150 degrees. Okay, right. That's that matter. Now, what I was saying here is that's a 45 degree. We got an angle of 49.23. So because of the wind blowing, the airplane is deflected with a slight degree measure, which is 4.23, right? So it's going at a 45, going perfectly, but wind is pushing, right? So it got deflected a bit, and then deflection, you might be asked find an angle of deflection, right? Rather than the actual angle. Then you say it's 4.23. 14 and 23, 14/23 minus the actual angle 45. Whatever difference comes up is the angle of deflection. We could have used angle between the triangle sine cosine formula, but not required here. Okay, now next question. Right, so let's go with the second question. Two cables hold an object static vertically. Cable A, as you can see here, cable A, this one. Cable A has a pulling force of 50 Newton in a direction of 30 degree with the axis, and cable B has a pulling force of Z Newton in the 60 degree opposite to x-axis, so it's 60 degree here. How much does the object weigh? So the weight is mg, and the pulling force is Z. So many questions that we will answer here. Right. First thing first, we talk about the vector A and B and the weight. So there are three components, and then sum of all the forces will be 0. Why? Because it's static, it's steady, right? So object is steady, the same place, okay? And that's why sum of all the forces will be 0. So from this cable A, we call vector A. Cable B, we call vector B, right? Weight is W, that's fine, and then sum of all the forces will be 0. And from there, we compare I with the I, J with the J, and we find the missing one. We find the weight as well, and then weight is equal to mg, we'll get the m. Okay, that's the process. Let's start. First of all, vector A. You can have bold face vector if you want. Vector A is AXI, AYJ. AX is the X components, R cos theta 50, cos 30, I 50, sin 30, J. Cos 30, root 3 over 2, so 25 root 3 I, and 25 J, sin 30 is half. That's my vector A. B. Now what happens with B? B is going here in this direction. What is the angle it's making with the positive axis? 120 degree. Okay, so that will be 120. B is BXI, BY, J, Y and J starting to look the same. Okay. BX is a Z cos 120, I, Z sine 120, J. Cos 120 is 180 minus 60. 180 minus 60. Second quadrant, cos is negative, so that's half. So minus is half Zi. And this is positive root 3 over 2J. That's my B. The third one is the vector W, the weight. What about weight? Now you can also consider vector angle 270 or simply r cos theta, r sin theta for W. It's negative y-axis, so cos will be 0, right? And only sine is, and any point here, say for example, this is 0, 1. This is 0 minus 2, yeah? This is 0 minus W. So that's it. It is only the J component, the Y component, yeah? So if I talk about the vector W, which is Wxi, Wij, it will not have the I component because it's straight on the negative y-axis, only negative y component. So can I say negative Vy? That's my vector W. Okay. I got all the angles. As I said, you could have also used 270 degrees if you want, right? Now, sum of all the forces has to be 0. Why? Because the block or the particle or the object in our situation is static. So, sigma, all Fi is 0. That is the force from this A, rope A or point A, B, and the weight W, they all have to be 0. Now plugging on the values, what is our A? A is I plus 25J. B is minus Z over 2I plus root Z over 2J. And this one is simply minus WYJ is 0 vector. It's a vector here. Now I have to say vector here. You can only a vector is vector, scalar is scalar. Okay. Now this vector, can I say is 0I? Okay. Every vector has two components, I and j. You can, if it's 3-dimension, you can say 0k. Okay. Now we collect the I and j components. So 25 root 3 minus z over 2I. There's no I in the third one. This is 25 plus root 3z over 2 minus wyj is 0I plus 0j. Yeah, compare I with the I. I with I and the j with j. So 25 root 3 minus z over 2 is 0. Therefore, z is 50 root 3. Awesome. We got our z. That was one of the questions. The other part, 25 plus root 3 over 2z minus wy 0. Yeah. We plug in the z. So 25 plus root 3 over 2 times 50 root 3 is wy. Right? We make it 25 times 3 75. Yeah, root 3 and root 3 becomes 325. 375 plus 25, 100 is my wy. That's it. So I got everything I need, yeah, in terms of the vector, right? But I want the m, okay? So weight is G is treated as 9.8, m times 9.8 is that. Therefore, the mass is 100. This is 100, yeah? Over 9.8. That is coming to 10.2 kg. Now, you might be wondering, why is the weight 100? Because the weight to vector is Wxi, which is 0. Yeah, so I don't write it. I already explained that part. So minus Wyj. Okay. So mode of, or sorry, magnitude of W is magnitude of 100 J. J is a unit vector. Magnitude of 100 will be simply 100. Right? And that's what this W is. So finally, I got the mass. Yeah, and I got the Z. How much was the Z? 50 root 3. Z. So that's our question. Yeah. The question asks you two parts. How much does the object weigh? The weight or the mass and the pulling force Z. So we obtain the Z as well. Hmm. Let's go to the next one. Those who are watching the lectures online via video recorded, I understand that you will have some reasons for not coming to the regular class. I don't want to go there, but I can offer support. If you want that, oh, I need some help, please come to week 12. If you can make it for one day, I'm happy to go back to any of the lecture slide from past and explain you. If you can't even do that, give me an evening slot. I'm happy to cater to your evening slot. Okay, say that if you finish school by 4 or 5 or whatever, I'm happy to one or two sessions after 5 p.m. If you're going to come. Some friction and some additional force and some force, XYZ thing, and that's why it's static. What is the friction force? Okay. Fine. Right. So we got only two parts of this one. Okay, so let's start with the F, the friction force. Okay, right? Now, Fxi, Fyj. Since it's a vertically placed, the y value, okay, it's a similar to that weight object situation where it was going on the y-axis and the phi only one component, right? This is moving on the x direction only, right? It's sliding, it's not going anywhere. Therefore, there is no influence of the y component. In the previous one, it was going in a y direction. Here, it's definitely not going in a y direction. It's just sliding across the x direction. So this component has to be 0. It's only the fx component. Okay, fy 0. And you can just, if you want fx, you can also say f. If it is only 1, you can say, but leave it as it is. Now the weight is something. Remember, we always measure with the x-axis. So if it is making 30° with the y, what is the angle it makes with the x? And that is 60°. So here, I will say wx, wyj, and that one is w, okay, just say wx, r cos theta, yeah. So R is W itself. weight is beta x component cos 60 plus W sin 60J. Cos 60 is half, so this is half WI, and sin 60, so root 3 over 2 WJ. So that is our vector W. Again, the object is static. Static means all the forces acting on the object or block or whatever we said should sum up to 0. Again, I was explaining, I'll explain it again, I'm assuming it may help someone. If you got a small bicycle, like a kid's bicycle, or just imagine some object, you're trying to push it and it's not moving. That means its own gravitational force, it's also a force, yeah, weight is equal to mg. It's greater than the force you are applying. So if you wanted to push it, you need to exert a higher force. So you need to push it hard. And sometimes you push a bit, that will move slightly. You push it faster, it will move even faster. You really bang like this, and it may hit the opposite wall. Okay, so your force that you are exerting is higher than its own gravitational force. Same thing with a car. Car has a bigger mass, and so the gravitational force, the stationary object, and like potential and kinetic energy, the potential energy of the force it carries is higher than the force you are applying. So it's not moving. Okay, but the moment it's a you really exert a higher force, like from some muscular body man, all this record breaker people, right? They have practiced and they developed that stamina to exert a higher force. Or it could be some crane or something. They push it, that's fine, because it got that much of weight capacity that is definitely higher than the gravitational force or the potential energy of that car, and that's why car can move. Over here, it's a static. That means the force exerted, applied to this object, they are all in equilibrium. So they all nullify one another, and that's why it's not moving. Right. So here, and W is a zero vector. F is simply fxi. W we know is half Wi root 3 over 2 Wj is 0. Collect the I and j part. So fx plus half W. This is more or less similar to what we just did. And root 3 by 2 Wj is 0. Okay. Now, if you compare 0, this doesn't make sense. Yeah. So we are not comparing. If you compare, you will get some result. But again, cross-checking the result is also important. We are not saying W is 0 and fx is, right? So we can obviously say that fx plus half W is 0 and fx is minus half W, right? Do we get all the data? Yes, we do. Weight is m and g. So that means my fx is minus half. The mass we have is 51 times 9.8. That is almost 80. So that is the fx, right? So the magnitude of the force, how strong is the force, is 215 Newton. Because then vector F is 250I. Yeah, and so its magnitude is capital F, which is 250 Newton. Cool. Okay, one more example. 3 vehicles, there's no diagram here, there's no figure here, which I like it. So you can create your own. Right? Vehicle A travel easterly or east with a speed of 100. B heads to west with a speed of 60. C travel with a speed of 80 northeasterly, right, in the northeast direction with an angle of 50 from east. Use the vector operation to find how far C is from A and B, respectively, in half an hour. Okay, seems scary, but it's not. It's really an easy question, I would say. Yeah, very easy question. And if similar question is there in the exam, it will carry significant weightage. So let's start with a basic diagram. Let's set this as A. Now, something that you should bear in mind, we are only considering half an hour. So if it's traveling at 100 kilometers per hour, let's set this up. So this is my A, because A is going easterly with a speed of 100. B is headed west, so this is my B, and C travels 80. That is my C. Okay. Now I should focus on the half an hour part. So let's say this is in half an hour A, right? C is 80, so in half an hour should be 40. This is 50, and this one is 60, so it will be 30. Right, that angle is 50 degrees. Cool? Because we are talking about half an hour. So we consider 100, we make a half of it. B is 60, half of it is 30. C is 80, half of that is 40. Why? Half is 4.5 an hour. And the angle made is 50 degree from east. So this is direction, 50 angle made with that. You can say 50 kilometer. This is 40 kilometer and 30 kilometer. Okay. Right. So let's build up a vectors. So you can say, oh, this is O, the mighty O. Yeah, O is always required. O. Okay. We'll have OA, OB, OC, and then from use the vector addition as vector C as, you know, A and B has been subtracted and all that. We'll see that. Okay, see that. Right. OA. By the way, OA is the same as vector A. But since we are referring to the origin, we are honoring it. Yeah. There is no J because it's going in the X direction. Okay. OB. Its vector B is going in the opposite direction, 30I. That's also I. Remember, it's also X direction, but opposite one. OC, or the vector C, right? R cos theta, R sin theta, 40 cos 50I, 40 sin 50J, whatever values. Oops. At 25.711 30.6418J. I would stress something here. Even though the question says 1 decimal, don't do it now because then it's called truncation error. You are truncating it a lot earlier than the final answer. So what will happen? It gets propagated as you move along, right? So if you're using C and C square and angle, then it's really getting bigger and bigger. So keep at least 4 or 5 decimals now. And when it comes to the final answer, okay, it will be fine if you are keeping it to 1 decimal because that's what the question is asking. Right. If you wanted to draw a simple, nice figure, like a triangle figure, makes sense. Let me pick up the green one. that is O, that is C, that is A, that is B, right? That's a 40. Okay, and that one is 30, that one is 50, and the angle is 50 degree as well. Okay, so that's what is happening right now. Okay. Okay, so we got up to OC. That's good. Now, CA, right? Now, many books would have done it their way, but I'll keep it simple. It's always the last minus first, right? If you want, you can create it like, okay, so you can always do it like this way. This is O, this is A, this is C. OA plus AC is OC. And then you come up with that thing. But couldn't go that longer. It's anyways a long question. Simply final minus initial. So final is A, initial is C. Okay, so that will give you 50I minus the whole C, this bit. Yeah, whatever that C is. Similarly, CB is B minus C. So minus 30I minus C, whatever that simplifies to. Yeah. What I'm interested in the length, because that's what we want. We want the length CA and CB, right? So length CA is the magnitude of vector CA, and that's why you need to complete that bit, which is 50 minus 2 pi 711 square and 30.641 square. You can all do the fancy longer calculation and finally come up as 39.0633. That is my CA. Similarly, CB is the length of the vector CB and with all the simplified form, and that is 30 plus 25,715 square plus 30.641 square. And that C will be 63.6 kilometer. Okay, so we got the CA and CB, and I think that's what we wanted, isn't it? So if this is the final answer, I can say 1 directly. Yeah, because if that's my final answer, I can read it in 1 decimal, so kilometer. And refer to the question. Yeah, how far is from A to B? So CA is 39.1 kilometer, and this is 63.1 kilometer. And from the triangle figure, it makes sense. Obviously, it's a lot closer to A than it's to B, because it's towards the x-axis, right? From the middle is towards the x-axis. Okay, so again, quickly recap. 3 vehicles, 100, 60, and 80. As drawn here, we are focusing on half an hour with an angle C for vector, with an angle 50 degree for the C. Find out all the vector OA, OB, OC, right? CA, it says final much first, and C C minus 2. I'm interested in institute, the part, let's see, and J part, and its length or the magnitude is 63.6. We will start this bit. Sorry, I didn't realize I was breaking that a bit, so I'll repeat what I said. We are talking about 3 vehicles here, 100, 60, and 80. A is 100. Just make sure we are focusing on half an hour. So that's 50, 30, and 40 with vector C making an angle of 50 degrees. Once you have that OA, OB, OC, the 3 vector with origin in the center, we are interested in the length. How far is this vector C from A and B? That's what we are interested in, this vector C or point C from A and B. So technically it's length, and that's why I've drawn this, this thing is here. So we are looking at CB and CA. So CA is that, whatever the final minus first, A minus C, the simplified form. Then we got CB, and finally its magnitude. Yeah. CA and CB. Cool. Let's look at the next part where we are involving integration for the work. So there are three variation for a work done, right? Various book would have various formula, but the ultimate force times displacement. Now, displacement is sometimes S, someone said D, that's perfectly fine, yeah? So if a force is exerted, if a force F exerted on an object and move the object over a displacement S, the work done by the force over S is equal to F dot S or S dot F, Newton meter, Nm, right? Since it's a dot product, you will recall from last week, dot product output is a scalar. So you will take both the vector, you have a dot product, and the output produced will be a scalar. So the work done will be scalar. Get an example to understand it. We got force F, 4i minus 5j. See, it's a vector. Is moving an object from 1, 1 to 3, 2. Find the work done by the force on the object. So if you have to draw this situation, I mean, you don't have to. So the object was at 1, 1, is moved to 3, 2. So x is 1, 2, 3. Okay, first of all, 1, 1 itself is not good. Three, 1, 2, 3. 1, 1 is here. 3, 2 is here. So 1, 1, and then it moved to 3, 2, right? It's not up to scale, so don't worry. It's definitely not a straight line. And that's your object A and B. Okay, from A, it has moved to B. X is 3, Y is 2. So find the work done. We're talking about this one. That's your object A. Right, so first of all, let's find out our S. S is the vector AB, I can say. It's the final minus initial vector B minus A, or you can also say OB minus OA. OB, which is 3, 2, so I can say 3i and 2j. OA, which is 1i, 1j, or I plus j. That will leave you with 2i plus j. That's my S. Now W, the work done, is F dot S. F is 4i minus 5j dot 2i plus j. Now the simple dot product, 4 times 2 is 8, minus 5 is 3. So work done is 3 Newton meter. That's it. That's it. I believe everyone is clear with this triangle law. If at all you are not, I can explain why this OB is OB minus OA and all that. Okay. So let me explain that, because I get that feeling that it might not be that clear. I mean, you would have done from your high school maths, but let's reiterate that. So what happens? There is this O, go to A go to B, and that's OB. So what happens? By the vector law or the addition, OA plus AB is the same as vector OB. So if I have to simply talk about AB is OB minus OA, is that simple, right? If I go to the earlier part, I think it was question 4, where I was talking about CA, I can also explain that OA and C is a similar situation, but I'll just explain it here. In that earlier part, what we had, there was O, A is here, C was somewhere here, and that's OC. OA plus AC is OC. And so if I want AC is OC minus OA. But if I want CA, remember AC and CA are opposite direction. Then I have to have a minus sign. CA is minus AC. So minus of OC is OA. And therefore is OA minus OC. But I would encourage you to keep simple. CA, what is the end point? End point is A. C is the head, right? If I'm talking about vector CA, okay, this is called the head, and this is called the tail. Tail minus head, final minus initial, that's it. So if I'm saying CA is the vector A minus vector C. You don't have to, I mean, you can if you want to, but you don't have to go into this triangle law of addition. They are all established. They are all nice and cool. Just use the established proof. It's similar to saying that, oh, if you wanted to use Pythagoras theorem, it's been proven. We don't go and prove it. But this triangle law of addition is proven that. So you don't have to go and unnecessarily increase your number of steps. Just use it. Final minus initial, right? And it's absolutely fine. But you should know how it is. And that's why I thought I'll just, go a bit deeper and explain it. So that one was a very simple example of work done. Cool. Now, we got two similar situations. Okay. The force is varied. And in other part, we will have S being varied. So what we are saying here, in the earlier version, if you observe here, F and S, they are both constant, right? F doesn't have any variable over here. F doesn't have any variable, they are just I and K, fixed force, right? And the S, which is AB, is also fixed, right? It doesn't have any variable, okay? But what if F contains some variation? And why would you need that? Okay. If I wanted to move a desk, the desk that I'm using, okay, if I wanted to move it, I applied some force, but it's not moving. So what would I do? I'll increase my force. So it's moved a bit, but it's not still at the point or how I wanted it. So I'll increase my force. So there is a bit of variation in the force being applied. So any situation like that, you are assuming force is a variable. Very shortly, we'll have one more thing where F is constant and S is varying. F is constant, you are applying the constant force, but the path is, having some variation in it. So in such kind of situation, we will use integration as our work done. Okay. So if it's varied, if you see some variable in force, then you are talking about dF here. But S is fixed, is unchanged during this moment. The desk is fixed. I'm applying more and more force. There is a bit of variable. Assuming F is time dependent, right? And that's why we take the time as our upper lower limit. The work done, W is equal to S dot dF from the time 1 to time 2. Simple formula and very simple example. Okay. Let's look at the example. So force FC, you see an I part, T part, the variable part in it. And S is fixed. Remember, you have your formula sheet with you. Okay, so if I were a student, I'll write the formula, and up here I will write the example that supports this formula. Only formula, of course, helpful, but not extremely helpful. So if I wanted to understand, I got the work done formula, but I don't know what is df, where will I use it? I know it's varied force and all that, but I have no clue. If I can see an example, will I be able to apply it? In that situation, I would jot down this example in whatever language, whatever, I mean, in English, but whatever paraphrasing you need, shorter, longer version of this question. Yeah. Cool. So we got f as a variable in bold. The object is moving from 1, 1, 2, 3 to same example in 3 seconds. So we got the time limit as well. Find the work done. So we know that we are looking at W is equal to time 1, time 2, S dot df, right? Time 1 to time 2, we have the upper limit in 3 seconds. So that means 0 to 3 seconds. So we got T1 and T2, 0 and 3. S, we already found one, is the same X as a DF. You got F, just find out DF, the normal differentiation. Very easy. Okay, so let's start with S first of all. S, which is same thing that we just did, 3i2j minus I plus j. So that is 2i plus j. You got S, lock it in. That's it. I'm not doing anything with it. What is my F? Is 3ti t square j. Then I'm talking about df. 3t differentiation, 3. Okay, and t square is 2tj. That's it. That's my df. I'll have a dot product. So the work done is 0 to 3. Okay. If you want, you could have just stretched this a bit, that df, right, is dfx by dti. Yeah. Because that's a time dependent, and dfy by dtj. But it's the same thing that I did. Right, 0 to 3. S is 2i plus j dot dot product. Simple. Don't worry about integration yet. Just the dot product. 0 to 3 plus dt. So 2 times 3, 6 minus 2t dt. 6 minus 2t integration. I'm sure you have done enough practice. What was it? 2t is t squared. 0, 18 minus 9. Upper limit 0 minus 0. And that gives you simply 9 Newton meter. Cool. Right. So like I mentioned, a force is constant, but direction has some variation during the movement, right? You're applying some force to an object, and then because the force or external factor, it took some varied path, right? I'm not sure how many of you follow cricket, but footy ball, you exert a force. Because of some factor, you expected it should go straight, but it's going in some various direction, or a bit of variation. I wouldn't say various direction, bit of variation than it's in its path. Yeah. So if we wanted to integrate, we will assume S is time dependent, and therefore work is F dot ds, right? I just wanted to clarify what we mean by this, because S will have some T part in it, because you are integrating with it. So technically what you are saying is T1 to T F dot ds by dt and dt, because you are differentiating S with respect to T, and whatever that comes up, you are integrating with respect to T. So in normal words, I mean, we don't treat it like this, but normal words, we say dt and dt got cancelled away. Or you divide and multiply dt, but it is not a number. It's the differentiation parameter, right? So we don't treat it like this, but in our brain, we can understand that it was ds. Now we are talking about ds by dt and we are integrating. So differentiation and integration being the reverse process, we are not changing anything. Okay. And therefore, we are talking about ds by dt. So similar to the previous one, when we have ds by dt, right? S will have I and j components. So it's dsx by dt I, yeah, and dsy by dt j part, yeah. So you just differentiate the I part, leave I, differentiate the y part, leave j with it, and that's your ds by dt. Let's look at an example, and obviously you can't go wrong here. Your f is constant. S has some variation. The t keeps on varying for pi second, right? Pi is a radian number, 3.14, but we don't want 3.14. We want it pi, 0 to pi, in other words. Okay? Right. So we know the formula. W is equal to T1 to T2 F dot ds. Okay, right. So we got F, nothing to worry. Let's find out S. S is also there. So let's go with ds by dt straight on. So as we know is dsx by dti, dsy by dt j, sine t differentiation, right? If you want, I can write one more step. Sine ti d by dt of cos t j. Okay, sine differentiation is cos I, sorry, and this is minus sine t j. Okay, now dot product with f. If you don't want to carry all the integration, you can just obtain it separately and then plug in here. I'm fine to carry it. This is 0 to pi. I'll write the limit as well. F, which is 4i minus 5j, dot product with cos ti sine tj dt. 0 to pi 4 cos t minus plus sine t dt. Cool. Now we integrate that. Integration of sine. Let's not forget ever what we have learned. Integration of sine is minus. I'm not sure if any one of you is still struggling with sine cos. Don't rely on a formula sheet for basic stuff. Since my early learning journey of trigonometry and its differentiation integration, I fixed one funda in my mind. Differentiation of sine is cos. And then all these four will play around. Differentiation of sine is cos. So integration of cos is sine. If differentiation of sine is cos, differentiation of cos is minus sine, and therefore integration of sine is minus cos. Yeah, I'm sure you are comfortable with it. You had a whole previous years into integration, so I'm sure you're comfortable. If not, just memorize it. Just don't depend on the formula sheet. So that's all integration done. Plug in the value 4 sine pi cos pi minus 4 sine 0 5 cos 0. Okay, sine pi is 0, cos pi is minus 1, so that's 5. That's a 0, that's a 1, so 5 plus 5, can I say? Yeah, because that's 0 and that will give you 10 Newton meter. So the work done is 10 Newton meter. That's it. Now, since you are a future leader, I would pass on some message saying that please encourage yourself and your student to have block in your answers. Just don't let your teacher find you. When I was marking first assignment, I was really struggling sometimes, right? And I written so many wonderful comments. I'm sure you would have seen that. And I'm just getting distracted for a couple of moments. Why can't you cross-check your answer? It's so simple thing to do. Unless you don't care about grades, that's a different story. But if you care about having higher grades, then you have abundance of time, more than enough than a 3 hours of exam format. It was a very simple thing to do is to cross-check your answer, right? So when assignment 2 is due, please make sure you are cross-checking your answers. Don't just leave it on your faith that, oh, I've done everything right. I'm 100% confident. And then you get surprise. It wasn't what you thought. Right? Don't leave it in the assignment. That's what I'm saying. With the exam, yes, we are time bound. Sometimes you can also cross-check an exam. Yeah, if you plan well, I wouldn't expect all the question. I mean, I prefer that you can, but if it's time bound, I understand if you can't. Okay, but please make sure. Yeah. So these are all the presentation skill. Before you think about it, my writing is not great because I'm writing on a screen literally vertical as you write on a wall. I don't have that trick. So if I was writing on my desk with this thing on, different story, but it doesn't work that way. Somehow it's not working for me. Yeah. And that's why my writing are terrible. If I write it on a piece of paper, it's far better than this. It's not great, but it's far better. Yeah. So make sure your writing is presentable. If not, have blocks, use more space, and all this thing. Yeah. That helps the reader. Cool. That's it then. We are done here with the vector. And next week, we will be going through complex number. There we'll be talking about body I. Okay, the square root of a negative number. So until that, take care. Any question, get in touch. Otherwise, good luck. We got only 2 weeks left. Please make best use of them and be prepared for what's coming. Take care. Thank you. Bye.